So in this lesson, we're just going to look at 4 practical examples of trig. Now, most of them are going to relate to duct layouts, simply because I know that's an area that often trigonometry is used, although that is an area that tends to be a specialty trade. And if you're somebody that's working, making custom ductwork for a heating and ventilation company, you're probably have had specialized training for that. As far as I know, there is a separate ticket you can obtain for that as well. I have a couple of cousins and they run a heating and I think it's heating and plumbing, maybe just heating. And they have a couple individuals on their staff that deal with just doing ductwork. So if that's something that interests you, if you're really good with 3D spatial reasoning, that could be a specialty area that you could specialize in within your trade. All right, so the first example we're going to look at asks us, what is the measure of side X in inches and angle Y for the following transition duct? So you'll see these 3 sides. So this would be the top. So it's the 12 by 14 that we have up here, 6 inches down. So this is our small rectangle up here. And then we have our diagonal. This is our X that we're looking for. So there's our diagonal. And then this piece is the base. Okay, so in order to be able to cut, see if my pen's working, in order to be able to cut this base piece, you need to know the dimensions of it. And then in order to find those, we need to know what is the length of that particular side. So the flat layout can really help us with that. So the first thing you would do in a question like this is you don't immediately maybe see a triangle. You don't see a triangle, look for one. And you need to make a right triangle, so we're going to cut this straight down. And there is our triangle. So nice and straightforward. So you've got our right angle. We have X here. We need to know our dimension. So we know this is 14 inches. 12, take away 6, leaves me 6 inches here. So we're left with a triangle. And sometimes it's helpful to just kind of redraw it on its own. So we have 6 inches and 14 inches. And X inches. So you can see you have 2 sides and a missing side. So that means we can use Pythagorean theorem in order to calculate it. So let's plug that in. So Pythagorean theorem tells us a squared plus b squared equals c squared. And that's going to give us 14 squared plus 6 squared equals x squared. 14 squared plus 16 squared will give you 232. Equals x squared, and take the square root of both sides. And you will find that 15.2 inches equals x. And if you take that 0.2 and you figured out, you could figure out how many 16ths of an inch. If you want to do it in 16ths of an inch, you could say 15, and I got 3/16 of an inch. Okay, so 2 different ways of expressing the same info. So that is our measurement for that missing side. Now for the angle. So the angle, we'll go back to our same triangle. We have opposite, adjacent, and hypotenuse. So we have opposite and adjacent, which means we use tan. So the tan of angle Y is equal to opposite, which is 14 over adjacent, which is 6. So the tan of Y is going to be equal to 2.333, and I think that just continues to repeat. So Y is equal to, and we do that inverse tan, that shift tan of 2.333. Y is equal to 67 degrees. Okay, pretty straightforward. Example 2, again, we have another potential duct layout. And we're told we have, this is kind of an interesting way to put this, we're told we have a 3¼ inch in 12-inch slant. What that means, when we write it like that 3¼ inches in 12 tells me the rise, or vertical, and run of a slope. Carpentry uses that often, but I found that an interesting way of putting it. We could also use the diagram to kind of help us figure it out, assuming it's drawn to scale. But we want to know, what is this angle? Okay, so in order to figure that out, rise gives me my 3¼ here. My run would give me 12 inches. Well, what is the angle that we need to have at this point? And the angle there, we can easily calculate again. So there's our angle. This is my adjacent side. This is my opposite side. There's my hypotenuse. So again, we're using tan. Now, in my understanding, or at least in my experience, most of the time when we're working in trades, we tend to use the tan ratio more than the other ones. Why? I'm not 100% sure, but it's just the way it works out. So the tangent of the angle is opposite, which is 3¼ over 12. Putting that in your calculator, tan of the angle is going to be equal to, put my page here with my solutions, 0.270. And that means our angle is going to be equal to, I have this angle symbol, you could put X there if you wanted, the inverse tan of 0.270. So the angle for X is equal to 15 degrees. And usually there's no need to be any more accurate than the nearest degree. If you wanted to be more accurate than the nearest degree, 1 decimal place at most for an angle. All right, example 3. Now this one's a little hard to see the measurements. I apologize. So I'll write them in here. We have 33 degrees. And this is 4.5 inches. All right. So we have 33 degrees and sorry, I just saw somebody walking across my backyard and I got second guessing what they were doing in my yard. My apologies for the delay. Staring in space for a moment there. That's the worst thing about doing stuff in front of windows. You get better light, but you have distractions. All right, so we want to figure out what's the length of the side that's marked. So this side here. So let's label them. We have our hypotenuse. This is your adjacent side, and this one would be our opposite side. So we have adjacent and hypotenuse. Cosine of an angle is equal to adjacent over hypotenuse. So the cosine of 33 is equal to adjacent, which is going to be 4.5 over our x. And this is one of those ones that flips. So x is equal to 4.5 divided by the cosine of 33. Putting that in your calculator, hopefully you can solve that at this point. Putting that in your calculator, you will find that the angle is 5.36 or approximately 5 degrees. Why did I put degrees? This is when I do blind things and I'm not exactly sure what I was thinking putting degrees. We're not getting degrees, we have degrees. I'm gonna go with 5.4. 5.4, we'll keep 1 decimal place, 5.4 inches. All right. Okay, now that we have that, the next thing that we need to do is we want to find out what's the difference in diameters. So the difference in diameters, if we could just kind of measure across here, the difference in diameter is going to be equal to this distance plus this distance here. We'll add those two distances together. So we can find one of them. If we can find this distance, we just double it, and that's the difference in diameter. This would be the just difference in radius. The difference in diameter is going to use tan. So the tan of 33 is equal to its opposite. This is my opposite, so I'll say opposite over 4.5. I've used that rather than the answer that we calculated before, simply because what if you made a mistake? And for me, I put degrees on the end of it, which really could have messed you up if you were copying it. All right. So I'm going to put an O in here, just. Oh, we didn't want a pointer. Okay. Put opposite. Okay. So the opposite side is going to be the tan of 33 times 4.5, which leaves us with 2.92 inches. 2.92 . Okay, the diameter difference is equal to 2 times 2.92, which gives us 5.84 inches, or if you wanted to convert 5 out of 5 7/8 inches, if you want to convert to decimal fractional inches. All right. So again, another one that's not very complicated. The most complicated piece of this one would be kind of thinking about how does diameter relate to the triangle, but I don't think that's too bad. And our very last one, I thought I had an extra one. What's the measure of the angle marked in this Y fitting? So we want to find out what's this angle. So the first thing we need to do is we need to make a right triangle that uses that angle. So just make a square, and then there's our hypotenuse. And we know this side has to be 25 and this side has to be 20. So there's my angle. Okay, so this is half of the angle that I'm looking for. So if we can find that, we're golden. So to find that angle, we're going to need to use tan again. I told you we tend to use tan a lot. So opposite is 20 over adjacent, which is 25. So the tan of the angle is equal to 1.25. Take the inverse tan. Don't forget that shift tan of 1.25. Our angle, so half the angle is going to be 51 degrees multiplied by 2 is 102 degrees in total. Okay. All right, so hopefully that gives you just a few examples. There's really not a lot. This would just be like if you were building a Y out of some pipe. You can figure out what the angle you would need to be to set things up at. But I want you to kind of think about where do you think you would use trigonometry, and or where it could be helpful to use if you haven't seen it used. And I'm going to have you just respond with that in a discussion, and any response to the discussion will give you a quiz mark. Okay, so just want you to think about applying it to your trade. You may find it would be helpful to know a little bit of trigonometry to find out an area or a volume. So you can kind of keep that in mind. If you knew an angle, or if you knew two sides and need to figure out the third side, where would be a scenario where you might need to use that? I've tried to sneak a few little bits in there, or feel free to talk to Alex. He may give you some extra reasons for where you would need to know your trade.